Probability, sample spaces. This situation now is different because there could be more than one thing happening. We're not just rolling a die, but you might be rolling a dice or die, and then you might be also picking a card or something. So there are more than one. It's not just single outcomes anymore. There's a fundamental principle of counting, and it says when one operation has m possible outcomes and a second operation has n outcomes, the total possible outcomes is m by n. So the first operation must be performed before the second operation. Going to stop and go do that again. Okay? I know probably some of you are stuck in that questionnaire, is that right? And I don't want you not to take the time to do that. So, I'd prefer to have you with me on this. Is that okay? And then maybe do that sometime between now and 2. Is that okay? Is that all right? And then, but I really want you to give that questionnaire consideration as well. And I don't want you to miss anything. Is that all right? I'm conscious that I didn't give it to half the class as well. So we'll give that a go. Is that okay? Sorry, Max. You can cut that again. Probability and sample spaces. What we're looking at here in sample spaces is where you have more than one possible thing happening. You might be rolling a dice or a die, and you might also be tossing a coin. So there's more than one thing. We're no longer talking about a single outcome. There's a fundamental principle of counting here in terms of and. When one operation has m possible outcomes and a second operation has n outcomes, the total number of outcomes is m times n. The first operation must be performed before the second one. And there's the equation. First operation and the second one, m by n. Now that's in the theoretical side, but let's look at what that might mean. We're looking, imagine now, at a 2-course lunch. You're going somewhere where they offer a 2-course lunch, and they've got 3 starters and 4 main courses. How many different combinations are there in total? So we can use S1, S2, and S3 to represent the starters, and M1 to M4 to represent the main courses. So S1, M1 is starter 1, main 1, starter 1, main 2, starter 1, main 3, all the way down to starter 3, main 4. 1, 2, 3, 4. There are 12 sets there of pairs. 12 sets, 3 and 4, related to each other to 12, 3 times 4. The total number of combinations is 3 by 4. Combinations, you've chosen starter 1 and main 1. You'll probably take them in that order, but you could take the main first if you were crazy and then go with the starter. But we're just saying that that's the combination. Okay? In cases of independent events, where one or more outcome is required and makes things generally harder. So the probability of A and B is the probability of A and by the probability of B. I slipped in the word independent there, and I'll come back to that. A and B and C is the probability of A by B by C. So there's probabilities generally if a number is smaller than 1, and you multiply by another number smaller than 1, it gets smaller. Half by a half is a quarter. Half by a half by a half is an eighth. So the probability gets smaller. So here's a 2-course lunch with 3 starters and 4 mains. What is the likelihood of a diner choosing starter 3 and main 4? So now you're saying, what's the likelihood of them picking that particular option? Starter 1, main 1, starter 1, main 2, starter 2, main 1, all the way up. 3 starters and 4 mains. What's the probability of starter 3 and main 4? Well, the only formula we have really is how many outcomes meet the condition. Well, there's only one of them. There's only one S3 M4 in the whole set. The total number of outcomes, 12. 1 over 12 is the probability. That's how we get that. Here we're representing the same question with the tree diagram. We're saying there are 3 starters and 4 mains. And 4 desserts now. We've moved up. We're going to have dessert as well. How many different lunch selections can a diner choose? Well, you have starter 1, main 1 to 4, and dessert 1 to 4. So you imagine that you could go in and pick this one, followed by this one, followed by that one. Whereas a friend of yours might go in and like starter 1, main 4, and might like the same dessert as you. So you can see that there are various paths there. And somebody else might have starter 3, then main 1, and dessert 1. And you could keep adding various rows here. And how many are there in total? It would get complicated to see them all. But for each starter, is there any reason why you couldn't have the main? No. Now, you might find that a lot of people take starter 1, main 1, and dessert 1. That might be the, vegetarian option for the starter and the main. You might see patterns, but there's no reason at the moment why we can't pick any one. So how do we do that? Well, for starter 1, we can say, actually, you can choose any one of the mains. So there are 4 different routes from starter 1. Similarly, we could say in starter 2, there are 4 different routes. So starter 2, main 1, starter 2, main 2, and similarly here, starter 3. And we can see how they begin to overlap. You can see the blue lines and the red lines from starter 1 and starter 2. Or if we were to go further, all 3 are in. So I've already picked up a lot of lines here between just the first 2. But what happens then when it gets to the main and the dessert? Well, for main 3, you can see that there are 4 paths from here. For main 1, I think, there are 4 paths in red. That's main 1 and main 3 showing. Or equally main 1, 2, 3 showing. Or 1, 2, 3, 4 showing. So there's quite a lot of networks there. And remember that once you get to main 2, you can have come from anywhere and go to anywhere. So the total number of possible combinations are, you have 3 choices for your starter, 4 times here and 4 here. It's 3 by 4 by 4, which is 48. Now, that's the way you get the number of options or the combinations. But what's the chance of a diner choosing a particular lunch combination? Well, if there are 48 different ones, and you're only choosing one, well then the number of ways of meeting, say, one particular option, let's say it's starter 1, main 2, dessert 3, there's only one of those options. So it's 1 out of 48. So here we've got starter 2, main 4, dessert 1. There's a 1 in 3 chance that the person will pick starter 2. There's a 1 in 4 chance that they'll pick main 4. And there's a 1 in 4 chance that they'll pick dessert 1. A third by a quarter by a quarter. And that turns out to be the 1 over 48.